All right, let's start off with number one. Sorry, did not indicate the direction there. I meant to say find the area. So find area. There's two ways that we can go about doing it. I think our first inclination is just to do top minus bottom. But if we do top minus bottom, we just have to understand that we may have to do two different regions here. Because if I were to draw one representative vertical rectangle, and I imagine infinitely thin rectangles from one end to the other, once it gets to this location, I've got a different top function, right? So we have to really think of this as two separate regions, each with their own top function. The bottom is the same for both, but different top function. So we're going to have to use our calculator, find an x-intercept, find the intersection, and find the other x-intercept. So go to our calculator. Hey, Ray, how do you see? Okay, so I have under y1 natural log of x minus 3. Y2, I have 7 minus 1/4 x. I'm going to just do zoom 6 just to see where that graph looks. And in a 10 by 10 window, it looks like my graph is going to be over here on the right side. So I'm going to push my x max. Right now, my x max is 10. I need my x intercept is probably over here, maybe in the 30s, 40s range. So I'm just going to play around with that. So I'm going to push that my x max out to maybe 30 or 40. Let's just see what that takes us. All right, so now we see everything that we need to see, right? So we have an x-intercept, we have a intersection, and we have another x-intercept. So I'm going to do second trace, intersect, 0. And I'm going to pick a point to the left of my first x-intercept, hit enter, and then pick a point on the other side of the x-intercept, hit enter a third time. We get 4. So the graph starts at 4. Second trace, intersect. Now I want to find the intersection between the natural log and the linear graph. Hit enter, enter. 17.346 and 2.66. Maybe I don't need the y value, but I'm just going to write down both my order, my full order pair there in case I need it. And then finally, my last 0. Okay, so I pick a point to the left, and then scroll over to a point on the other side of the x-intercept, hit enter, and I get 28. So I got all the bounds that I need to do my area. So I can go from 4 to 17.346. Top minus bottom. The top of my rectangle is sitting on the natural log. The bottom is sitting on the y = 0. So natural log of x minus 3 minus 0 dx. So that completes the left region. Okay, so now moving on to the other region here. This is going to be the 7 minus 1/4 x, but it's a different region. I'm going to start from 17.346 to 28. And this region, the graph on top is the line, and the bottom is still the y equals 0. Okay, the rest can go in your calculator. I can drop the zeros now. I just wanted to show the 0 initially just to show that I am following the formula top minus bottom. But if you drop the zeros in your calculator, that's fine. So math 9 for both. Any questions? All right, part B, number 2. We have our shaded region. Notice the boundaries they tell us: natural log of x plus 6, y equals -3, and x equals 5. Notice that they don't indicate anything about the x or y axis. So the x and y axis are just the background. It doesn't. It's not any boundary for our shaded region. So we're not going to just ignore it. Ignore the x and y axis, just there to give you some perspective. So we have our natural log, y equals -3, and x equals 5. Okay. We're going to revolve around the line y equals -4. So you see the word revolving, you know it has to be either disk or washer method. So if this is -3, then -4 is going to be below it. Clearly, there's a gap. So washer method. So extend from your dotted line to your 2 boundaries. First boundary is all the way up to this natural log graph. Second boundary is the y equals -3. Okay, let's build our 2 radius. Top minus bottom for big R. So the top of my radius is sitting on the curve, the natural log of x plus 6, minus the bottom. The bottom is sitting at -4. Careful though, we have 2 negatives here. One for the formula between top and bottom function, and then the other negative is coming from the axis of revolution. Next up, small radius, top minus bottom. Top of my small radius is sitting at -3. The bottom is sitting at -4. So -3 minus a -4. Two negatives cancels out. I get 4 minus 3, which is 1. I do need to find my boundaries. The right boundary is easy. That's just going to be 5. But the left boundary, I have to figure out where that intersection is because I need the x value there. And also, your calculator is not able to graph a vertical line. So you just have to draw that in yourself. But yeah, your calculator can't do a vertical line. Y equals -3. I'll do zoom 6 again. Now it does keep going. It's just that the vertical asymptote is kind of hiding it a little bit, or it's kind of disappearing because it's so close to the asymptote here. So you may have to zoom in that region if you want to have a better chance of finding that intersection. Well, actually, I think we can do it. We can just do second trace, intersect, and then just pick a point on the curve, hit enter, pick a point on the line, hit enter, and it should find that intersection for us. Okay, yeah, -5.95. From everything's in terms of x. So that means our bounds also in terms of x. So as far left as -5.95, as far right as 5, and we're only looking at the shaded region. Make sure both your radius are getting squared separately.
Should left bound be where natural log of x plus 6 intersects with the AOR?
No, it doesn't touch the AOR.
Okay.
Remember, active revolution has no say as to what your boundaries are.
Okay.
Your bounds is just the shaded region. Yeah. And that goes for area, disk method, wash method, and cross section. Just shaded region for your bounds. Okay. Typically, I like to leave pi out of the calculator and then just attach it at the end. And now we're talking about a three-dimensional calculation, so cubic units. Okay, questions so far? Okay, keep reminding yourself that area is just top minus bottom, right? So I think we do this in Washer method so frequently that we sometimes fall into the trap of following the same formula for area. So make sure area is just top minus bottom. We don't square anything. We don't put pi. It does feel a little empty, and so students start adding things to it because it doesn't quite seem right. So, but area is just top minus bottom. Okay. All right, good with first page. Oh. Same shaded region. But now we're going to be rotating around x equals 5. And x equals 5 is this right boundary here. So there's my axis of revolution. Notice your axis of revolution is right up against the flat surface of your shaded region. There is no gap. All we need is one radius. However, you got a vertical axis. Your radius has to come out horizontally because your radius and your axis will always meet at a T. So, but all we need is one radius, no small radius. This is just this method. Now, if we want to do right minus left, or if we want to do a horizontal radius, we have to do right minus left. To do right minus left, we know that it's going to be a little bit longer setup, right? Because these equations, this equation is not going to be a good fit for.
Good morning. Damian Warren, will you please come to the front office? Damian Warren, please come to the front office.
So this curve, this natural log of x plus 6 needs to be rewritten. So let's spend some time doing that. Initially, it was y equals natural log of x plus 6, or natural log of x plus 6 equals y. But this is not the form we want, right? We want the form with the x by itself. So to get x by itself, I'm going to raise both sides with e as the base. E and natural log cancels out. Subtract 6 from both sides. This vertical line is x equals 5. So we now have the forms that are suitable for our right minus left. Notice your equations are no longer y equals. They're now in the form of x equals. And x equals indicates whatever's on the right side is ready for you to use for your right minus left. Okay, so all we need is one big radius. Right endpoint is sitting on the 5. Left endpoint is sitting on the adapted equation, e to the y minus 6. Careful though, we do need to put a parentheses around that left function. We need that negative to distribute. Okay. Volume equals pi integral. What do we have to do with the bounds? In terms of what? What variable? Y. So lowest to highest, okay? So one of them is easy. The low one is easy. What's the lowest y value? -3. Okay. This top one here, it's not as hard as it looks. You may be thinking, oh, I'm going to set these equal to each other. You could set these equal to each other, but I think the easier way is this. This graph originally is the natural log of x plus 6, right? Do we know the x value at this point? What's the x value at this point? 5. So if I want to find an ordered pair, I can just plug that 5 into the function and get the y value, right? So I don't have to do, I don't have to play with other messy functions. Just use the original one, right? I know the x value, just plug in and find the y. So plug 5 in for x, natural log of 5 plus 6 is 11, natural log of 11, or you can use a decimal version of that. So sometimes I see students, they get really tripped up with this vertical line, but really you can just use the original function. If you have the x value, just plug in, get the y value. So the highest y value is this point, and that point has a y value of natural log of 11. Okay, big radius gets squared. Okay, natural log of 11 or 2.398. Big radius quantity squared, 472.739 pi cubic units. Okay, number 3. We have the region root x plus 6. That's going to be the radical function. That's the one on top. And then e to the x plus 1. That's the exponential function. That's the one that is rising. Find the volume of the solid generated when the enclosed region is revolved around x equals -6. Let's graph both these functions, find those intersections. But x equals -6, it's probably going to be somewhere over here. Zoom 6 gives me that standard window. Maybe I want to do a zoom box just to kind of, we don't really have to since everything is there. Okay, we go through our intersect feature twice. Once to find that left bound and other to find. So pick a point close to your target, hit enter twice, and it's going to find that x-intercept for you. -4.986. And then do the same thing on the other side, closer to the other intersection that you want the calculator to find for you. Enter, enter, 0.428. Okay. Clearly, this is going to be washer method. There's a distinct gap. Also, there's no flat surfaces anywhere on the shaded region. So no matter where we put our axis of revolution, it's always going to be washer method. Okay. So from your dotted line, you're going to extend to the graph that's further away. That's going to be your big radius. And then the one that extends to the closer one, the shorter one, shorter distance will be your little r. But again, it's a horizontal radius, so we know these equations are not going to be a good fit, right? We have to spend the time to actually rearrange and solve for x. Do the square root first. Y equals square root of x plus 6. If I want to solve for x, I'm going to square both sides. X equals y squared minus 6. So x squared equals y squared minus 6. Let me color code it here. So this is the radical function, which is the one on top. All right, meanwhile, we have y equals e to the x plus 1. E to the x plus 1 is equal to y. I would like to solve for x, but let me get that e to the x by itself first. So I'm going to subtract 1 from both sides of the equation. I want to bring that x down, but that x is sitting in the exponent. Let me take the natural log of both sides to take advantage of my log property. The x comes down. Natural log of e just goes to 1. So x equals natural log of y minus 1. So this is going to represent that exponential function that we've termed. All right, big radius. Right minus left. Big radius is starting off all the way over here on this curve that I highlighted in pink, which is the natural log of y minus 1. Minus right minus left. The left endpoint is sitting all the way on this dotted line, which is a negative 6. Careful though, we got to keep track of these negatives. Right minus left. Okay, moving on to small radius. Right minus left. The right endpoint of my small radius is sitting on this orange highlighted line here, which is y squared minus 6. Right minus left. Left endpoint is sitting on the axis revolution, which is at negative 6. So y squared minus 6 minus a negative 6, which is plus 6. So this cleans up all the way to just be y squared. Because the negative 6 and plus 6 cancels out. So, oh, I messed up. I indicated the x values, but I really need the what? I need the y values. Sorry. Let me write the full order pair. Everything's in terms of y. My big radius is in terms of y. My small radius is in terms of y. My bounds also in terms of y. The lowest y value that I see is 1.007. The highest y value is 2.536. Big radius squared minus little radius squared. $26.032 is what I got. Pi. Page 13. Any questions so far?
When you're deciding what to subtract the AR, is it like it's either right minus left or top minus bottom?
And again, the order, because it's because we're squaring our result, the order is not going to matter. But just make sure if you want to do bottom minus top, that you're putting a minus sign in between your bottom minus top, or top minus bottom. But yeah, you can do it either way, but just make sure that you're following that formula, that you're keeping track of the negatives. All right, last two here. Same shaded region as before, but now we're talking about building isosceles right triangle with hypotenuse on the base on top of this shaded region. Okay. First order of business, we got to figure out which direction this is talking about. Parallel to the y-axis, which direction is that? Vertical. Yeah, y-axis is vertical. Parallel, we stay in that same orientation, so vertical. That's nice. That means we can use the original functions. No need to adjust anything. The bounds we found already, just pick out the x values. Okay, so we're going to kind of build it piece by piece, right? Let's start with the base. Top minus bottom. The top is sitting on the square root. The bottom is sitting on the exponential. Careful, parentheses. Next up, let's get to the second dimension, which is area. We want area of this triangle with hypotenuse on the base. It's 1/4 base squared. So we'll insert this base into our formula. And then our third dimension is just adding that integral with the bounds. No pi, right? You can put the 1/4 out or in, it doesn't really matter, as long as it's there.
It's just telling me this like every time. And I try to plug it in like different ways and stuff. Or should I just leave this?
You may be missing a parentheses that's causing
I-
an issue.
I put a parenthesis in that.
Maybe the parentheses need to be a little bit more.
Yeah.
Yeah, but it's not all or nothing. I mean, I'll
Okay.
give you partial credit if something is off. .581. Is that what you guys got? All right, number 4, shaded region. This is negative x squared plus 4 is the parabola that opens down with y-intercept at 4. g of x is the negative 1/2 x plus 2. We're going to rotate around the line y equals 4, which is going to skim the surface of the top of the curve. Okay, what is this going to be? Disc or washer? Washer, right? It's touching, but that's not good enough for it to be disc, right? It's got to be a flat surface up against the dotted line if we want to call it this method. Okay, so washer method. Vertical radius, that should make it easier. No need to rewrite our equations, just have to be able to know where your radius is going to extend to. Make sure that the dotted line is always included as you build your big R and little r. Graph your two curves, find your x intersections, x value intersections. If you do alpha y equals, I think that'll get that. Alpha y equals n over d, I think. My intersections was negative 1.186 and 1.686. Okay, top of my radius is sitting on the 4. The bottom is sitting on the linear, the negative 1/2 x plus 2. So 4 minus, careful with your parentheses, with that minus sign. Top minus bottom, top of my small radius is sitting on the 4. The bottom is sitting on the parabola, the negative x squared plus 4. Looks like the 4's cancel out. I'm just left with x squared for small radius. Washer method, make sure both radius gets their own exponent, gets their own squared. Wait, are you come back later?
Yeah.
I'll
Okay. Thank you.
Okay, let me go around and see if you guys have any questions. If you have any calculator issues.
Like, where,
Yeah, so sorry, this, I meant to say area, that's why fraction. So this one, you can think that's two regions. Top minus one. I don't think so. Individual variables.
It's like this.
oh, this year, what is this? I plugged it in. It's this wrong. Yeah.
Wait, I think I
Cause I don't know where I'm playing. I don't know if I played it wrong.
Wait, did you know that we tried helping them? The entire thing? No, like, so I don't know. I started with the second back process, like, around my
Oh. I would multiply by 1/4. Yeah.
What about one?
I could just write it on the
The reason why is because if we don't, then which top function do you choose? Because the top function is this top. We don't have a consistent top function. It can, because this change in top function, I mean, in this is two separate. It's being consistent.
Wait.
Right, so the -1/(x+2), that's a linear thing, so we know that's gonna be the line. And then the -(x+4) is a parabola. So you're asking, how do you know?
Yeah.
Okay. So you know that's big R, you know that's little r. Okay. All right, what's the top of big R sitting on? Okay, so that's your top. What's the bottom of big R sitting on? With this, here, that's something like that. So it's 4 minus the line. Here, small radius is 4 minus the third. Make sure you put parentheses after the minus sign.
You guys like a doctor's appointment, but she was wondering if she could take the quiz in the class.
Yeah, she can, it's up to, I'll be the teacher.
So go to the teacher.
Teacher lounge, yeah, on this hall, yeah. I think that 3307.
Okay. Yeah. We know.
So scary.
I didn't study.
So okay.
I was like.
You should go. You should ask. And be like, doesn't really know.